the hands-on project. Coefficient of restitution, experiment time 3 p.m. 4 combinations chosen for the calculation of the coefficient of restitution is nylon ball dropped on acrylic and aluminum plate and stainless steel ball dropped on acrylic and aluminum plate. Select a combination of a ball and plate, then set the ball to 25 cm above the plate, drop the ball beside a ruler, and measure the bounces in between.
The coefficient of restitution is a method of measuring the relative elasticity of an impact between the scale of 0 and 1. Coefficient of restitution can give us a lot of insight on which materials to use for things such as sports gear or sports equipment, and even car safety, determining which type of metal will keep passengers the safest.
Once we have recorded all the heights, we can use the below equation to calculate the coefficient of restitution for each jump. Then we can take the average to find a guesstimated value for E.
The goal of our experiment today is to measure bouncing balls of various materials and use the equation for coefficient of restitution to determine whether our values line up with real-world values determined experimentally.
Our maximum E value was found by our nylon and aluminum combination, and our total minimum was found by the stainless steel and aluminum combination.
Our best bounce was nylon and aluminum as well, which had 9 bounces, and our worst bounce was stainless steel and aluminum, which only had 3 bounces. Our stainless steel and acrylic had the most accurate measurement, with our research values at a 7.5% error.
Based on the data, the coefficient of restitution is relatively constant throughout bounces. The error result was relatively small, so we can agree that the experiment was successful. For the next experiment, we'll be using nylon ball on acrylic. There are a few things that can cause an error in the experiment. There are parallax in barrel, air resistance, and impurity of materials. The uncertainty of measurement tools and human error also is a source of error. Based on the experiment, we believe that the theory we found on the internet was incorrect. It stated that steel has larger E than nylon, while in the experiment, nylon ball was more bouncier than steel.
Suggestion for a better result is to use a clamp to release the ball. Do not assume the ball as a point mass. Drop the ball in a vertical transparent tube. Do more experiments and average out the measurement, and take the video using a tripod.
These are the resources we use to find our real value of E.